First, I'm going to go up here, watch party, make sure I get this right. 25.44 minutes. Click. It didn't go. Work. Let's back up one screen. Looks frozen to me. Could this be? Hi, this is Lee Furseth at the Headwaters Science Center in Bemidji, Minnesota with a 3:30. Today it's a watch party for our live show, and it's going to start in just a couple of minutes. I wanted to tell you before it starts that today's show is underwritten by Beltrami Electric Cooperative. They Water Science Center with a grant so that we could put on these shows for you. So thank you very much to Beltrami Electric Cooperative.
Okay? We've got to have, they're rolling down ramps that are about the same height, the ramps are the same length. And they're coming onto the same kind of surface, and they're both bowling balls, pretty much the same composition, the same characteristics of their outer covering, and they're both 14 pounds. So, all right.
Frightened when they are feeling threatened and think they're going to get eaten. One of the things that they can do as a defense mechanism is drop off part or all of their tail. And so with Einstein, what she did is she just dropped off maybe the back third here, and that's called automy is the word for that, where they drop off the tail and can regrow it. Because the tail doesn't need to get ripped off, they can do it themselves. It's basically like they have a little ring of muscle, a sphincter of muscle that they can kind of squeeze together, and it pinches off the end of the tail. Even like a loud noise will make them drop their tail off sometimes. Ours, remarkably, like I said, that's the first. This just happened maybe 3 months ago at this point, where this one fell off, and we had this gecko here for several years before it happened. And that was the first time it had ever dropped off a piece of its tail. Ulysses, the other one, has been here for a little over 2 years at this point, and at this stage still has its original tail. So you can kind of tell they look a little different. The shape on this one has actually held up pretty well. Sometimes when they come back, they're kind of like short and stubby and bulby when they grow back. So it's a little discolored. The pattern on the back is a little different, but shape-wise, it has held up pretty well. You can actually see, I actually have the piece of tail that she dropped off. We collected it the next day, so we don't even know what caused her to drop off her tail. We just found the tail piece.
Impossible, his father said. I just want you to know the word impossible probably says to most kids, you should try it. If somebody says to you, that's impossible, chances are someone's going to go, I'm going to prove you wrong, and off they try. In fact, scientists are all about that. They're all about, well, that's impossible. So Portley says, I want to try something else, and his dad says, impossible.
Now we have alcohol. Burning, protects the rag, switches the rag, in this little contraption. something that happens in a natural setting.
Hello, this is Keturah, Maine, coming to you live from the Headwaters Science Center. We are doing our 3:30 show.
Hi, this is Lee Furseth from the Headwaters Science Center, and today we're doing a watch party. Sorry for those technical difficulties. We had difficulty getting our video to play, and now we've selected another one for you. This is a video that first appeared about 2 weeks ago, and it is one of our Science Center staff, Keturah, Maine, doing a cryogenics show. So I hope you enjoyed this one today, and here we go.
Today on cryogenics and the states of matter. We're going to be looking what happens to those states of matter when things get really, really cold. Here in Minnesota, we think we know what really cold is. So I have a little thermometer here, and you guys can answer these questions, right or wrong. Any answer is fine. So we think we know what cold is here in Minnesota. It gets pretty chilly in the winter, doesn't it? Yes. So here we have a thermometer. You guys know how a thermometer works, right? Cold, warm. You'd be amazed at how kids in northern Minnesota, about this tall, oh yeah, they know exactly about a thermometer. What do you wear when you go outside? So we are going to be looking at how states of matter, how molecules that are in that matter react to very cold. So up here we have the temperature that water boils. Would anybody like to guess at what temperature water boils?
235.
That's very close. It's a little too high.
212.
212, very good. Temperature of water boils right there. Here is a body temperature, average body temperature. Anybody like to guess what average body temperature is? Just take a guess.
98.6.
What do you think?
96 degrees.
Very close. 98.6 is what they say is average. But as we are noting, because everybody's taking everybody's temperature right about now, is it really varies. But that's kind of an average. You get to 100 degrees, then you're kind of cooking pretty well. So we are right about 100 degrees. Water freezing. Oh, us Minnesotans, we know all about water freezing, right? What temperature does water freeze? 32 degrees is the temperature that water freezes. A cold winter day, it says minus 20. They don't know Minnesota very well. Then we have the coldest temperature ever recorded on Earth. I'm going to cover it up. What do you think is the coldest temperature ever recorded on Earth? What do you think?
Negative 120 degrees.
That is very close. 129 degrees is what it says on this thermometer. It's actually been recorded a little chillier than that now, maybe about 132 degrees, and that is in Vostok, Antarctica. The coldest place that's ever been recorded. Doesn't mean it's the coldest temperature, it's just there were people there to record it. There's people that live in the coldest place on Earth. Who do you think is crazy enough to live in the coldest place on Earth?
Scientists.
Scientists, you are so right. They have a little station there. They stay all winter long. Once they're there in the winter, they can't leave. It gets too cold where machinery doesn't work, their airplanes don't work, gasoline turns into kind of a gel. So machinery doesn't work very well, so they are stuck there over the course of the winter. And there was the doctor. She diagnosed herself with cancer while she was there over the winter, and they couldn't leave. So they did a dramatic drop of equipment to her, and she was able to treat herself while she was there. So you're stuck. If you're there, you're stuck. And amazingly enough, people decide they want to go back over and over again. All right, coldest place on earth. So now we are going to look at a very chilly temperature of the stuff that I happen to have right in here. This is liquid nitrogen, some very chilly stuff. And the liquid nitrogen is way down here, 321 degrees below zero is the temperature of liquid nitrogen. So we are going to use that liquid nitrogen to look at the states of matter, to check out molecules, to see what happens to them when they get really cold. Now you guys know that there's molecules everywhere, right? Stuff is made of molecules. This is made of molecules. This is, you guys are made of molecules. Really tiny little parts that you can't see very well. But it's really important to know what happens to them when they get really cold. So, well, first of all, let's just take, wait, I forgot something. All right, 3 states of matter. I'm so glad I have my props, otherwise I would. Oh, yes. What do you think? Either both of you go for it.
Gas, liquid, solid.
Nice. I didn't even need the cue cards. Awesome. Gas, liquid, and solid. Very good. Those are our 3 states of matter. So we're going to be looking at what happens to gas and liquids and solids when they get really cold and when they warm up. So first we're just going to take a look at our liquid nitrogen. I'm going to be getting some of it out. Oops, I got to take my mask off for some dramatic effect. So what I want you to think about, answer, is what does this stuff look like? What color is it? What do you think?
Liquid nitrogen is crystal clear.
Crystal clear. Very good. Any other guesses? Blue? Purple? Let's take a look. So in this beaker, I have, or a flask, sorry, this is not a beaker, this is a flask, is liquid nitrogen. All right, I will walk slowly in. That is liquid nitrogen, 321 degrees below zero. What does it look like it's doing? Boiling. Exactly, it is boiling. Boiling is not a temperature. Talked about temperature that water boils at. This boils at 321 degrees below zero. So it is boiling. Boiling is just changing state. Remember we talked about the states of matter? It's going from a liquid to a what?
Gas.
Gas, very good. Changing states. That's what boiling is, going from a liquid to a gas. And we got some other stuff going on here. What's this stuff on here? Frost, very good. How about this cloud of stuff? What is that? Yes, excellent. Kind of like fog. Very good. So that just kind of gives you an idea of what this stuff looks like. Oh, and put a balloon on top of there. And we are going to capture something in this balloon. Said it was turning from a liquid to a what? What is in the balloon?
Gas.
Gas. Excellent. Very good. It is a gas. One thing you'll notice is it starts off with just a small amount. I just put a little bit of the liquid nitrogen in here. But look how much the space it takes up as it turns to a gas. So this is what happens. When things get warmer, they get farther apart. Molecules, there's little molecules in here. Same molecules are in here, but they're just much, much farther apart. More active, moving around a lot. So this is gas. Now, the question is, What kind of gas? Oh, just wait, I'm gonna get some of these. Very good though. This was liquid nitrogen. What kind of gas do you think would be in the balloon? What do you think?
Carbon dioxide or nitrogen.
Very good. It is nitrogen gas. 100% pure nitrogen gas. As this went from a liquid to a gas, and since it was very well sealed, it is all nitrogen gas in this balloon. Pure, 100% nitrogen gas. So this is something I haven't done for a while, and oh, I will do it again just for you guys. What do you think would happen if I would inhale this pure 100% nitrogen gas?
So you get the giggles.
What do you think would happen? What do you think?
You're gonna get very cold.
I'm gonna get very cold, my lungs will get very cold. Good guess.
Your voice would slightly lower.
My voice might change, another good guess. Any other ideas? Anybody thinking like it's a really bad idea and I might fall over and die?
Yeah.
Yeah. People are just very polite. I know you don't want to say that. All right. What I don't do for science. All right. So I'm going to back up a little bit because I take my mask off to do this. I will now inhale this pure 100% nitrogen gas. Nothing happened. I know, you're kind of disappointed. You were ready to like start CPR. I appreciate that. Nothing happened. Pure 100% nitrogen gas. Well, let's talk about what you guys are breathing in right now. Okay, first of all, what state of matter are you breathing in and out? Gas. Excellent job. Gas is what we're breathing in. I know it sounds a little weird, but that's what we breathe in all the time. Gas. So there's a lot of stuff in that gas. And in the Science Center, there's probably a little extra weird stuff in it. But what are you breathing in every time?
Nitrogen, oxygen, and water.
Nice. Very good. Anybody else want to add anything? Carbon dioxide is another thing you said a little earlier. So every time you're breathing in, you are breathing in nitrogen gas. And as a matter of fact, you're breathing in more nitrogen gas than anything else. Just a little bit of oxygen and a lot of nitrogen gas. So I think we need a little fresh nitrogen. Don't we feel better? Back here, we need some fresh nitrogen. Oh, we feel so much better. All right. Now what we're going to do is do some things with solids. One thing we talked about was how when things warm up, went from liquid to a gas, it took up a lot more space. The molecules got much farther apart. So now I'm going to get this thing. What is this thing called? A bouncy ball. That's right. They called them super balls when I was a kid. But gotta get with the times. This bouncy ball. I'm going to put this bouncy ball into the liquid nitrogen. Let it get a little chilly. And while we're waiting for that to cool off, I'm going to show you some solids, right? Would you say this is a solid? Solid, yes. This is a solid. Molecules in a solid are very close together. There's still a little space in between them, but it's very close together. So I have this little ball, and it fits through this little hoop. And I'm going to put this little hoop into the liquid nitrogen. We're going to see what happens to it. Because, you know, it's important to know here in Minnesota what happens to things when they get really cold. Because you want to get out on your snowmobile and get to your walleye hole when it's 20 degrees below zero, and that machine goes from 20 below to very high temperatures. And they need to make sure that it's going to work, because you want to get out to your walleye hole. All right, so here's a very cold little ball, super ball. What do you think is going to happen when I drop it? What do you think?
It'll either shatter or just stay there.
Shatter, or it'll just like fall? Good guess. Any other guesses? Let's try it. Some of my favorite words. Let's try it. Those are like my 3 favorite words. Are we ready for the dramatic camera action? It bounces like a marble. It even kind of sounds like a marble. The molecules in this ball got closer together. It got more solid. So it's changed its properties a little bit. And as it warms up a little bit more, it starts to bounce more like a potato. And eventually, it will get its bouncy ball qualities back, even after all that chill. Now let's see what's happened to let's see if anything changed. Remember that the little hoop went through, or the ball went through the hoop? But it does not go through anymore. Went through before. Do you think this is bigger? What do you think?
It got smaller.
This is smaller. Does it look smaller? Can't really tell, can you? But you know, there are scientific tools I bet you we could find that we could measure it and tell. But you can tell just by this. This does not fit through there anymore. So the molecules in the solid got even closer together with the chilly temperature. Eventually it'll warm up, and I bet you this thing will fit through again. You'll have to wait for that. In the meantime, I have a question for you.
Yeah.
How many people have gone out on a cold winter day and put their tongue on something metal? Who's done it? Who's done it more than once? What I like is when somebody says they've done it 3 times, because that is a true scientist. You do something once and, well, you know, it could have been a fluke. Do something twice, well, it kind of probably. Do it 3 times? Yeah, it's a thing. So, all right, what I don't do for science. If you have a quarter, if you give me a quarter, I'll lick it. Anybody have a quarter? I have no change. All right, I'm gonna back up my mask again. All right, I said, if you gave me a quarter, I'd lick it. Oh, you wanted me to like this? Oh, no. I'm not gonna do that. No way. Oh, you guys, you want me to breathe in nitrogen and lick really cold things. All right, I will now get this really cold, get the science germs off of your quarter. There. It's a little chilly. I like to touch it. Isn't it cold? Do you think the molecules in that quarter got a little closer together? Just a little bit? All right. So once again, we have a gas. We have a liquid. That's why I have spares. All right, let's see how this one does. All right, so what is in the bottle? What did I just put in there? Go ahead.
Liquid nitrogen.
Liquid nitrogen, excellent. What is in the balloon? Gas, excellent. What kind of gas? Go ahead. Nitrogen. All right, we gotta do one for this side of the room, right? Oh. Oh, science is great. You guys like science?
Yeah.
Oh, science is fantastic. I love science. You get to play with all the best toys. I mean, tools. Not toys, tools.
Toys.
And toys, yes. I highly encourage you guys to stay in the science classes, and take the ones you don't like. You know, I took a lot of classes I didn't like, but they can help make you smarter. Like math. Math is hard. Math was hard for me. And there's a lot of things in the world that are hard. You know, like playing a violin. Do you think you're going to be good at a violin the first time you ever pick one up? Do you play the violin? It's hard, isn't it? And you
Until
practice.
you learn it,
And you
it is
practice.
decently hard.
Yes. And good for you. And so a lot of things are like that. It's good for your brain. Playing a musical instrument is good for your brain. Learning to do math is good for your brain. And playing with balloons is good for your brain. Good catch. And those are for sale down in the store. I think they are anyway. They used to be. I don't know what's in the store. But they're great to bring to a big occasion. You know, something especially very serious like a graduation. I have 2 pennies. And there's an older penny from the 1980s and a newer penny that is after the 80s. Well, they changed the metal that is in a penny. It used to be copper, and now they are zinc. Very different types of metals. So we're gonna see what happens when we get these cold. We're gonna start off with the copper one. And we're gonna get that very chilly. It was about in the 80s when they figured out that there's more than a penny's worth of copper in a copper penny. So there's actually people that have been hoarding pennies for years. They have like garages full of pennies. They're waiting until a penny is no longer legal money. And then they can melt them all down. But for right now, you're supposed to be nice to the money. Anyway, here is a copper penny, and it was able to withstand that cold and pressure. Now we are going to take the copper, or no, this was the zinc penny. Zinc is a silver color, but they put a copper coating on it because we don't like our change to change. We want it to look just the same. So zinc is a very different type of metal. It's more brittle. It's not as bendable, so we're going to get that really cold. And we don't know anybody that works for the U.S. Mint, right? Because I've heard they don't like their stuff damaged. One more chop. I'm going to bring this around, and you can see that that zinc penny was not able to withstand that cold and pressure, and it broke into pieces. All right, I'll come over this way. There is chunks of the copper penny. This is the zinc penny. And once it thaws out, you can even see that it's a silver color on the inside. And now they're thinking that zinc is too valuable, so they're not sure what to do with pennies. I think they should get rid of pennies and not have them be legal tender anymore. So then those people that have hundreds of thousands of pennies in their garage can get rid of them.
I have over $2 worth of pennies. Oh, yeah.
I think they are a fun thing to collect. All right. Oh, do you guys like scary movies?
Yeah.
They're so scary. But you know, I do like zombie movies. But the people in zombie movies, oh my gosh, you know, what do? They walk right into the graveyard. They could walk around the graveyard. No, they walk right into the graveyard. Because what are zombies? Where are they hanging out? Hanging out in the graveyard because zombies are what? The living dead, right? So where are you going to be? In a graveyard. So these people in these movies, they go right through the graveyard. Well, besides zombies, we need special effects in the graveyard.
Is it cold? Yeah.
Isn't it great? Isn't it just like cushy? It's almost soft. I know, it's a little freaky. We are going to make a fog machine. Now we're going to come back here. And you can make
Smoke rings.
fog rings. I didn't get you back here. Nice. I'll take my mask off again. I should do this ahead of time. So we've been looking at states of matter, solids, liquids, and gases, and we found out a little bit about what happens to them when they get cold and when they warm up again. So in here we have a state of matter. What is in this balloon?
Gas.
Gas. Very good. There's gas in this balloon. What do you think will happen if I put this balloon into the liquid nitrogen? Very nice. It will. Very, very good. The molecules are going to get closer together. So the balloon gets much smaller. And what happens as it warms up?
It gets bigger again.
Bigger again. Very good. So we're going to try a little trick. It is a little chilly to hang on to this stuff. But I'm not putting my fingers in liquid nitrogen. Although you can touch it for a very short amount of time. Some people probably have. They go to the doctor and they say, oh yeah, they'll tell me all about the warts that got removed. So it is something that you might have come in contact with at the doctor's office. So I put this in here because this friend of mine, she used to work here at the Science Center. And she loved doing these programs. And it's her birthday. I hear somebody just had a birthday yesterday. And a couple days ago. And who doesn't like a balloon for their birthday? So I get her a balloon and put it in here and send it to her in the mail. And then she'll get a balloon that came from the Science Center, a place that she loves and she misses the children. So I thought it would be kind of a fun present. But I see there's going to be a problem. How are we going to get the balloon out of this container? Any ideas?
Or liquid nitrogen on it.
So we pour liquid nitrogen on the balloon. The balloon shrinks, and then the liquid nitrogen goes underneath and expands and pushes the balloon out. Very good. My three favorite words again. Let's try it. Let's try it. It worked. Oh, nice. Very good idea. Very good. So, this has been the 3:30 live show from the Headwater Science Center. Thank you, my live audience, for coming and watching, because it's always more fun when there's real people there that I get to interact with and talk to. Thank you for tuning in, and the Science Center is open on Friday and Saturday from 9:30 to 5.
And let me take over for Katura. Thanks for watching today. Today was a 3:30 STEM watch party with Katura, Maine, doing a cryogenics demonstration. This is Lee Furseth, and just before I sign off for the day, just want you to know that today's show was underwritten by Beltrami Electric Cooperative. They are supporting us on our 3:30 shows. And I want you to know that we are open on Mondays. So we're open today. Happens to be Monday when this show is being rebroadcast. We're open today until 5:30. And then we are also open on Friday, Saturday, and Sundays. Friday and Saturday is the same as Monday, 9:30 to 5:30. And Sundays, we open at 1 and we stay open until 5:30. Tuesday, Wednesdays, and Thursdays, we're here available to schedule groups. So if you're a teacher or a student, we would be welcoming you here for a field trip on a Tuesday, Wednesday, or Thursday. Or if you're a scout leader or you're a group organizer of some sort and you want to come here on a Tuesday, Wednesday, Thursday, give us a call. It's best if you call Monday through Friday, and we'll work away at scheduling that group trip that you'll make here. Again, thanks for watching today, and this is signing off on our 3:30 live show.